in a process which is known as emulsification, and this emulsification is conducted in the presence of emulsifiers. Emulsifiers are basically the surface active agents which directly put the charge over the water droplets or the bitumen combination droplets. For an example, milk is an emulsion of butter fat droplets in water. Similarly, we are making emulsion using a bitumen as well as water. So, can you tell me, is there any other examples of emulsion which you have seen in your daily life? There are many examples of emulsion which you deal with in your daily life.
Mayonnaise, sir.
Yeah. Any other? There are too many examples like paint we are using. Paint is there, and jelly. The people we eat, the people which eat jelly candies. It is also a type of emulsion, and it is first developed in 1990. And the early use was in the spray application and to control the dust over the roads. And in 20s, the asphalt emulsion came into picture for the paving purposes, like for the surface course. Bitumen emulsion is basically a liquid form of highly viscous bitumen, which is prepared with the addition of water and is converted to a low viscous material so that it can be easily used on the for the paving purposes. And in which a water is a continuous phase and bitumen is a dispersed phase. Like you have seen the addition of oil in the water, there are different processes. Like we can add water in the oil and oil in the water, or it may be a combination. The bitumen particle in the emulsion droplet is about 3 microns in diameter. It is so minute that it is even less than the strand of a human hair, which is about 9 micron in diameter. And also emulsion can be formed by two immiscible liquid, but in most of the emulsions which we are dealing with, the one phase is water in each case. And proper care has to be taken to identify the stable emulsion so that it does not allow the separation of bitumen from the water. Like you are seeing in this picture, second one, the emulsion, the oil is not mixed with the water. And in the first case it is basically a stabilized form of emulsion, which is showing a mixed homogeneous composition. So proper care has to be taken to identify these type of stable emulsions. This is the form how we can convert the emulsion, how we can prepare the emulsion. Like first one, you can see the oily particles are in orange and the dispersed phase is water, like the blue one. And in the second, you can see it can also be prepared with with the addition of water in the dispersed phase of oil. And third, we can have a composite structure like water in oil as well as oil in water. The different components of bitumen emulsion includes the in it is basically first the water. There are two different cans. One is the bitumen and second is the water, and these all two containers are mixed together in a colloidal mill where they are mixed and separated into a fine droplets. And it also include the addition of different surfactants, additives, and basically these are types of emulsifiers which are added and mixed together in a colloidal mill, and then it is taken out, and the product which is the final product which we obtained is basically the emulsion. In a bitumen emulsion generally contain 40 to 75% of the bitumen, where 0.1 to 2.5% is emulsifier and 25% to 60% is water, and there are some different minor additives also. And in the paving construction, generally soap or surfactant is used as a emulsifier to provide the surface charge on the surface of the bitumen. This is the emulsion phase. Like emulsifier is showing the positive and negative charge over the surface of the bitumen particles and bitumen droplets, and it is dispersed in a water phase. And this is a figure of colloidal mill where the bitumen as well as the water is mixed. This is basically the bitumen tank, and this may be the water tank. They are mixed together in the form of in a mixer type colloidal mill. The structure of the bitumen emulsion, it generally includes a tail as well as a head, where the tail is directly mixed with the bitumen part because it is a hydrocarbon part, and that bitumen is also a long chain hydrocarbon material. And the head part generally provides the negative as well as the positive part and help in the proper coating with the aggregates. It is the figure is of cationic emulsifier, which where the head is showing that it is a water-loving component, and in the anionic emulsifier molecule, the head shows the water-hating component. This is a figure which shows that emulsifier always act at the interface of aggregate as well as bitumen emulsion. Like you are seeing, the surface charge are on the surface. The charge is on the surface of the aggregates, surface of the binders, which is positively charged, and the other component like aggregate is a negatively charged particle here. So before how means the bitumen emulsion is coated over the aggregates. There is a process where the bitumen emulsions break down so that the water should trapped out from it. So this process includes states that over a period of time the bitumen phase will eventually separate the water from it. How it separates the water? Like bitumen is insoluble in water, and the breakdown of emulsion involves the fusion of droplets, and the process is known as coalescence. You can see, I will tell you in detail in the next slide. Like first, the bitumen droplets in the emulsion may have a small charge, like it is told that if it is a droplet there will be a negative charge on the surface of the bitumen emulsion, and the source of the charge is basically the emulsifier as well as the ionizable components of the bitumen itself. Bitumen is also having some charge. And third, these small charge may provide a electrostatic barrier, which if it is a positive charge, then and the other component like the aggregate is having the negative charge, it will attract each other. Otherwise, if the aggregate as well as the emulsion is a positive charge, then it will repel each other. So there is always an electrostatic barrier between them. However, when two droplets do achieve enough energy to overcome, then they try to flocculate, like they try to come together to each other. Like this is the process of flocculation. It will come over a period of time. Oh, the flocculation factor may also can be recovered if over the period of time with the addition of more amount of emulsifiers or with the addition of surfactant or by vibrations. Over a period of time, this water layer between the droplets in a floccule will thin and the droplets will come together to form a big globule. Like this all small droplets will join together and form a big structure, and the coalescence cannot be reversed even with the addition of additives, even with the addition of with the subjectation of vibrations. And the factor which force the droplets to come together is the settlement under gravity, evaporation of water, shearing or freezing, and this will help in acceleration of the flocculation and coalescence process. And the lower the viscosity, the higher rapidly will be the coalescence of the binder. Of course, we want the emulsion droplets to coalescence after the addition of the or in the contact with the aggregate. So it is very difficult to find the proper emulsion, as there are different type of emulsion which can adhere to the aggregate in a less time or in a more time. So it is a bit challenge to find the emulsion proper or satisfying stable emulsion. The classification of emulsion is based on the setting type, where it sets on the road surface, and other is on the base of surface charge. For on the basis of setting type, emulsion can be of three types, like rapid setting, medium setting, as well as slow setting. All these structure is depend on the type of emulsifier used and the quantity of emulsifier used. For the surface charge, there will be anionic emulsion, which is having a negative charge on the surface, and a cationic emulsion, which is having a positive charge on the surface of bitumen emulsions. As per the literature, it can be seen that in India, the cationic is mostly used and is a versatile type of emulsion which is used for the paving purposes. Although there are anionic as well as non-ionic emulsion, but cationic is mostly used. It is because the aggregate which is used in India are mostly the siliceous aggregate, which is having a negatively charged particles, which are basically negatively charged, and because of this, there is a proper or good bonding between the cationic emulsion as well as the siliceous aggregates. The setting type bitumen emulsion includes states that the rapid setting bitumen is a type of emulsion which breaks down rapidly as it comes in the contact of the aggregates. It basically helps in fast setting as well as fast curing. That is why it is mostly used for the road construction or for the surface layer of the flexible pavement. And second is the medium setting. This type of bitumen emulsion does not break when direct applied on the aggregates. This process requires evaporation, or when the fine dust of the mineral are added to it, it forms a proper coating over the surface of the aggregates. Third is the slow setting emulsion. In this type of emulsion, a special type of emulsifier is used to slow down the process of water evaporation. This type of emulsion is basically stable, but it takes a larger time as compared to the rapid and medium setting. So can you please tell which type of emulsion do you use in the construction process, whether it is rapid setting, medium setting, or slow setting?
Sir, for
Both, sir.
primer we are using slow setting, and
Okay,
for surface course we are using for tack coat we are using RS rapid setting.
rapid setting for tack coat.
Yes,
And what about medium setting?
sir. I am not using it.
Any other?
Slow setting and rapid setting we use, sir. Rapid setting for tech code, same. Medium setting I have not seen, sir.
Okay, okay.
Sir, but nowadays that RS and SS are not produced from the refineries, so only MS is available. So we don't know how to use.
Okay. And based on the surface charge, we can see that the tiny droplets of the bitumen are electro positively charged, and it is known as a cationic emulsion, which are mostly used in India. And second is the anionic emulsion, where the tiny droplets of the bitumen are negatively charged. Like you can see in the images, the surface is positive charge for the cationic and negatively charged for the anionic based emulsions. And this figure is shown that if the binder as well as the aggregate is positively charged, there will be a repulsion between them. And if the binder is negatively charged and the aggregate is also negatively charged, then also repulsion will occur. And if there is a different charge on both the types of material, then there will be a proper attraction. And due to which the bonding is very good between the aggregate as well as the binder. The different terminologies which is used for defining the emulsions are the name of the emulsions, like RS is known as a rapid set, MS is a medium set, and QS is a quick set. Can anyone tell that they use quick set emulsion in the paving construction or not? Means you have not used, I think. And there is a HFRS based emulsion where the floating time is very high, and it basically sets very rapidly. And AE is denoted for anionic emulsion and C is for cationic emulsion. And the nomenclature if we have to use, because in the box it is only written HFRS2, it means high floating rapid setting high viscosity bitumen emulsion. Like for the CSS1H, it is known as cationic slow setting low viscosity hard bitumen. That number like RS1 RS2 denotes the viscosity of the binder. And if it is written like P is written, it means the binder basically which we have used for making the emulsion is a polymer modified asphalt binder. The typical bitumen emulsion recipes includes for cationic rapid setting emulsion, asphalt content is about 65%, and the soap is used for as a emulsifier, and the water is a dispersed phase where we are adding the oily particle or the asphalt in the water. And for for cationics, slow setting base emulsion, asphalt content is around 60%. And the soap or emulsifier content is relatively higher, that is 3 to 7%. And for the asphalt anionic rapid setting, the asphalt content is again 65, where the soap content you can see is around 11 to 12%. And for anionic slow setting, also the soap content is around 10 to 12%. The figure clearly shows how the emulsion get coated over the aggregate. Like initially I told you that it is coated with it shows the different negatively and positively charged materials, and due to over the period of time the absorption of free emulsifier is there, means the effect of that surface charge reduces over the period of time. And after this the flocculation occur, and after when these flocculation, these particles come together, adhere to each other, then they form a proper big composite, and is allowed to coat over the aggregates or spread over the aggregates, and that process is known as coalescence or coagulation. The recommended use of bitumen emulsion is RS1 is generally used for the special recommendation of the tack coat, and RS2 is basically used for the surface dressing work. And for the medium setting emulsions are used for plant or road mixes with coarse aggregate only, with a minimum 80%, and all of which is retained on the 2.36 sieve. And it is basically used for the it is frequently used for the surface dressing as well as the penetration macadam. And slow setting one is used for the applications where related to the fork seal, crack sealing, prime coat applications. And can anybody tell the difference between the prime coat and the tack coat? Anyone? There is a big difference between the prime coat and the tack coat. Because you are working with these type of things, that's why I asked this question. So prime coat is basically the application of bitumen emulsion between the unbounded layers like the granular layers with the bituminal binder layer. And tack coat is basically done to bind two asphalt layers, like one is the old one, other is the new one. Like if it is the pavement surface, if it is granular layer and it is a binder layer, then here we will apply prime coat. And if it is a binder layer and between a wearing course and a binder layer, we generally apply tack coat. So for SS2 based emulsion, it is recommended for the graded and fine aggregates, road type of mixes. And the example of its use are basically the cold mix, MSS, HDBC, and slurry seal. And can you please tell that if you are constructing HDBC MSS, for rural roads, I think MSS is constructed nowadays, or the surface dressing. Anyone can answer. Okay. There are different advantages and limitation of the emulsions. Like the advantages is the maintenance, it can be used in a maintenance and the repair work in a very easy way, efficient way, where we do not have to take our whole machinery. We directly have to take the emulsion in a packet or in a container, and directly we can use to bind the repair the deformed part. And it can be used in the wet weather also. Even if it is raining, then also we can use the emulsion, but it is not possible with the bitumen to work in the wet weather or rainy conditions. It is basically eco-friendly because it does not require any temperature for processing, mixing or laying. And for the soil, it can also be used for the soil stabilization. And it is also having anti-stripping properties that that eradicate the effect of moisture on the flexible pavement. There are several disadvantages also, like the storage time of bitumen emulsion ranges from few days to 6 months, depending on the percentage of the bitumen added. So if the time is more, storage time is higher, like 8 to 10 months, then the bitumen emulsion will settle down, and there is a problem of settlement. And the setting time is basically dependent on, also dependent on the temperature conditions. If temperature is higher, then they may settle down, and if the temperature is lower, then they may be stable. And the working with emulsion may depends on the aggregate type as well as the nature of work. Like I have shown that the emulsion is directly based on the nature of the work. Like SS2 is used for different application, RS1 is used for different application. That is why it is dependent on the application part, road part, and the aggregate part also, because there are different type of emulsions. I have told that there are surface active agents are there, like negative charge, positive charge, aggregate emulsions are here there. And the using of this is dependent on the type of aggregate, whether the aggregate is negatively charged or whether the aggregate is a positively charged. So the proper care has to be taken to work with these type of materials. That's why it is more complex than the, its chemistry is basically more complex than the that of a normal or complex, already complex material, that is bitumen. There is one crude field test which is conducted to identify the
Mayank,
yes, yes.
I would like to, so that you don't tell this test now. We will ask them first at the end.
Okay, okay,
That will be better.
okay. Then I would like to call Mohit for the testing part, which is conducted on the emulsions. I think he will start, so I am disconnecting my presentation. I am stop sharing this.
So what does 1 and 2 indicates in RS1, RS2, sir?
I have, that RS1 and RS2 indicates the 1 and 2 indicates the viscosity of the binder. Means like this I am showing you here.